So this is our lecture number 11 in the series of logistic regressions. In this lecture, we are learning about the features importance and what is its model interpretability of this feature importance. So let's start. So let's take in our model we have d number of features. So first feature is f1, second is f2, third one is f3. So simple, jth one is fj, and the last one is, let's take fd. Okay, and corresponding for these features, our optimal OAD is equals to, let's after solving our optimization problem, let's find our optimal OAD vector is w, and w is also belonging to its d-dimensional space. So let's for features 1, w1, the first component is w1, features 2 w2, for features 3 its component is w3, and for features j its component is wj, and for features d its component is wd. Okay, this is responsible this. Okay, now we assume that here all our features, first we are assuming, here our assumption is that all our features are independent. So first assumption, what is our assumptions? All our features are independent. All our features is independent. Let's first assume it. So these assumptions are also we are making naive-based classification model. These assumptions already made. We are seeing this assumption is naive-based classification model. Okay. And if you just remember the probabilistic approach or probabilistic interpretation of the logistic regression, so there we are considering two considerations. First one is the Gaussian naive Bayes, means our features are linearly independent, Gaussian naive Bayes considerations. And second one is we have that it is a Bernoulli. It's follow the Bernoulli distribution. Okay, it's follow the Bernoulli distribution, means all the features are belonging in real number and it is Bernoulli distributed. We are seeing it in logistic probability interpretation of logistic regressions. So now the main concept is the feature importance. Means what? Features importance is means wj features importance means age wj is responsible, age wj is responsible for age features. So here wj is responsible for features j. So features importance means the importance of wj's, means that if we alternatively speaking wj, we are finding after solving our optimization problem, we are finding our optimal w, and w is built to w1, w2, w3, wj at that wd. So the important features, we have to select the important features, means we have to play with wj's. And we see that if you remember the knn, if you remember just knn, then here we will see that features importance in knn, features mean importance, how to find the features in patterns. Here we are finding the features important using forward feature selection method or backward. So simple, we are taking here forward feature selection method in knn features importance. What we are used here? Here we have used forward feature selection. Okay, and naive Bayes. In naive Bayes, how we find our best features? Here we are finding the probabilistic approach. You are just remember in naive Bayes we are finding the probabilistic approach. Suppose probabilistic approach is equals to class 1. Here we are finding this probability for best features. Here we are selecting our given data point. For a data point for given class, we are seeing the probability for features which are important. Okay. In logistic regression, here we are using the weight vectors, the component of the weight vectors to determine our features important. Suppose simple as short we are writing it fi. So in KNN we are writing the features important by using forward or backward feature selection method. In naive Bayes, Gaussian naive Bayes, we are using the probability concept for features which are important. Here in logistic regressions we are using the W's component of W vectors, that is weight vector, to determine the features important. Now how the main thing is that how to compute, using the weight vector, how to compute the feature important. So first we are computing the absolute value of our W's. That is the absolute value of our weight. Absolute value. Sorry. First we are calculate the absolute value of our weight. Okay. Weight corresponding to our features. Okay. Now let's take the primary concept of the logistic regression. Let's consider. So here our Wj, suppose let's take if our Wj is large, then what? If our Wj is large, then the multiplications of W transpose and our query point, that is we called as xq. If our Wj is large, then what all about multiplications of query point with this W, then it will be also large. Okay, it will also be large. Now consider two cases here will arise. So suppose in case 1, if Wj is positive and if Wj is negative, then what happen in the situation? Case 1 means what? If Wj is equals to positive and large. Okay. Now what? In such cases what happen? If Wj are positive and large, then simply our multiplications of Wj into our query point of the j, that is where j is belongs to 1 to d. Simple. This is mean what? This is means nothing. This is mean our this. Okay. This is simple thing. This is simply our dot product wq into xq. Okay. If these both are positive, then this is positive and large. This is also chances. Its chances will be positive and large. Okay. If our Wj is positive and large, then multiplication of this term will be chance increases, it will be positive and large. Then what? If this one chances increases positive and large, then what we have conclude? Then we are conclude that our P of YQ belonging to positive class, chances is increasing also, its chances increase because our transposition W transpose AQ, its chances increased. Okay, I think in case where you are all able to understand, if WK is positive and large, then the multiplications of the query point is also positive and large. If this quantity positive and large, then our probability chances also increases these our query point in belonging into positive class. Now let's consider our case 2. If Wj is equals to negative and large, if Wq is negative and large, in such situations what happens? In this case, our multiplication, if we see our multiplications Wj and Xqj, when j is equals to 1 to d, then its multiplications also. If our Wk is negative and large, then what will be the multiplication result? The multiplications also chances that it will decreased, its value will be decreased. Okay, because Wj is negative. Okay, so in such situations what happen? In such situations our probability of the negative class also increased. So we see two cases. If our Wj is positive and large, then we see that our chances, the query point increased in positive class, it belonging in positive class, its chance increased. If our Wj is negative and large, then our negative class chances also increased. So it is simply we are see this thing in lecture 1. Now to determine the important features in logistic regression, first we have to calculate the simply the absolute value, because what, simply if we consider the both the cases, if we just take in the absolute value, then we can find if the absolute value is large, then we can simply conclude that the features is more important. Simple, let's consider an example, then it will be clear, I think. So first we have to determine, just write down it. We have to determine the importance. To determine the importance features, determine the features in logistic regression. So we are calculating what, the absolute value of our weight vector. Okay, now let's play with an example. Let's play with an example. So suppose we have to predict the gender of him. So our main thing, we have to build a model to predict the gender. Okay, predicting gender, our main task is the predicting the gender, whether it is a male or female, or here we have two gender. Our main task to predict the gender, whether it is a male or female. So in male, let's take M, and or in female, let's consider it as F. Okay, so here in these cases we are using two features. Here we are using two features. What features? Our first features is that hair length. Our first features is hair length, and for hair length our weight vectors is WHL, hair length. Now our second feature is the height. Okay, so for height our weight vector is simply WH. Now if we consider the simple as a general concept, if we apply the distributions of the hair length and the height, then we can find that our hair length is the more important to predict the gender. Just simple if we just draw the distributions, if you distributions the height, if we distribution the height, the distribution to main, this is the main distribution and this is the woman distributions. This is for men, this is for men for female, men and female, male and female. Okay, if we see these distributions for the height, that is if we distribution with the height, then you can, it is the most overlapping this area. Okay, this is the more overlapping because we cannot properly conclude it height. But if we see the distributions of the hair length, to the, then if we draw the plot of this, then you can clearly see here that it is less overlapping from it. So here we can conclude that hair length, it's a general concept. If a male, in a male the hair length is short, and for a female the hair length in large, but we cannot properly predict from the height. If a height, it will be male, and it is height it's large, it will be female. From the height it is not properly clear, but from hair length it is clear. So in this sense we can see that the hair length is more important. So, but how in the logistic regressions, how to determine? So here we can determine the absolute length. If we determine the absolute value of the weight of the hair length and the weight vector of the height, then we can find the here weight of the hair length is negative. Here weight vector of hair length is negative, but its absolute value it's large. Then what will be the probability? Then its probability will be that its class is negative. Means what? Its class is negative means this class it will be belonging to female. So large, simply if we conclude is a single word, these both things are conclude that large negative weight value. Okay, large negative weight value. Okay, now for height, if we consider the height, that is height, we are taking here height. For height we are taking here h. Okay, let's for height we are taking height. So if we consider height increased, then probability also increase. It is a simple concept. If our height is increased, then it is simple concept that the probability the person will be male, it is increased. That is, person will be male means query point will be class 1, it is increased. That is our male. Chances increased. Chances increased, it will be male. So in this case we see that our weight vector of the height, this will be positive, but it is not large. For what? It will be here, it will be medium. It will be medium and positive, wait, and positive. It will be medium and positive. But why it is medium and positive? Because for height increases, our classes will be, it will be the male, it is increased. Okay, but it is not important as here less important. So for this length, this the absolute value will not be large. This absolute value will be medium, but the hair length, the absolute value of the hair length will be large, because for our hair length, importance of the hair length is so much. You can simply see the distribution. The importance to predict the gender hair length is more important because it's more overlapping. Sorry, this is the less overlapping than the height distributions. Okay, for this reason, the absolute value of the weight vector is most important to predict the features important in logistic regressions. I think it is clear. If you have any doubt, please comment below. Then I will try to give your answer clearly. Okay, thank you.